This video will show you how to do a second problem for the Precal test review. So we have a problem statement here. A right triangle has one vertex on the graph of y equals x to the 8th, x greater than 0, at xy, another at the origin, and a third on the positive y-axis at 0y, as shown in the figure. Express the area A of the triangle as a function of x. So this at first appears to be a fairly complicated problem, but we do know a lot of previous things about how to do this problem. We know that the area of a triangle is 1/2 the base length times the height. Now we'll go over and look at the diagram that they so thoughtfully gave us. So the base of this triangle is going to be the distance x, and this is going to be the height of the triangle. And we actually have a function for that. It's y, and it's also equal to x to the 8th. So if I want to go write area of this triangle as a function of x, it's going to be 1/2 times the base length, which is x, times the height, which is x to the 8th. If we simplify that, that's going to be 1/2 x to the 9th. And we'll go try putting that in for the book. So I'm going to put in a fraction, 1/2, move out of the fraction x, rooftop, 9. I may have said 8, but I really meant 9. So check answer, and the book liked that. So we'll acknowledge that. And we're on to the next problem. I'm going to click similar question. A rectangle has one corner in quadrant 1 on the graph of y equals 4 minus x squared, another at the origin, and a third on the positive y-axis, and a fourth on the positive x-axis. See figure. So they were nice enough to give us a drawing. So what do we know about the area of a rectangle? It's going to be base times height, or length times width. So the base here is going to be x. The height here is going to be y, which is 4 minus x squared. So area as a function of x is going to be our base, which is x, times the height, which is the function 4 minus x squared. So the book probably wants us to simplify that. So let's distribute the x. So that's going to be 4x minus x cubed. So I'll go put that into the book. 4x minus x rooftop 3. Check answer, and it liked that. So now it's going to ask me, what is the domain of the area? The area function, really I would have called it a of x. So the domain of a. Okay, so in words, domain is all the numbers x is allowed to be. So if we were just looking at this from a mathematical standpoint, so f of x equals 4x minus x cubed. There's no possibility of division by 0, there's no variables under a square root, and there's no log containing a variable. So mathematically, the domain would be from -infinity to infinity. But without specifically saying so, this book really isn't asking that. It's saying, for this situation, what is the logical domain? So I'm going to do the domain for this physical situation. So if I had x equals 0, I couldn't even have a rectangle. So I'm going to put a parenthesis to signify that this is an open interval. So I can't quite be 0. I could have a very tall, skinny rectangle without much area that would look like that. Okay, now if I go 4 minus x squared, when would that equal 0? Well, the answer to that is when x equals 2, because 2 squared is 4. So I'm going to have an x-intercept here at 4, 0. So I can go all the way up to, but not including, sorry about that. So I could go almost completely up to 2, but not quite 2. So my domain is going to be the open interval 0 to 2. So we'll go try that. So I'm going to put in the template, 0, shift over 2, check answer, and the book likes that. Now it says graph a of x. For what value of x is a the largest? So I'm going to go to the calculator, start a new problem, doc 4 for insert, 1 for problem, 2 for a graph. So 4x minus x cubed, and I actually have only this part of the function makes sense for the physical situation. So I'm going to change my window. Menu, window zoom. I want to decide my own graph. So I'm going to say from -1 to +3, put a tick mark every 1, and I'm going to leave the y as it is. So I have a graph. The start of my domain is just past 0. I reach a peak here, and then the logical end of the domain is here at x equals 2, just below 2. So I'm going to go Menu, Analyze Graph, and now I want maximum. So I'm going to click 3, put the lower bound to the left of the maximum, upper bound to the right, and we get 1.15. Going back to the book, round to 2 decimal places as needed, so I'm going to put in 1.15, check answer, and the book liked it. So that concludes the second video.